Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Security Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You need to set up a cloud interconnect connection between your company's on-premises data center and VPC host network. You want to make sure that on-premises applications can only access Google APIs over the cloud interconnect and not through the public internet. You are required to only use APIs that are supported by VPC Service Controls to mitigate against exfiltration risk to non-supported APIs. How should you configure the network? The options are: Option A, enable private Google access on the regional subnets and global dynamic routing mode. Option B, set up a private service connect endpoint IP address with the API bundle of all APIs, which is advertised as a route over the cloud interconnect connection. Option C, use private.googleapis.com to access Google APIs using a set of IP addresses only routable from within Google Cloud, which are advertised as routes over the connection. Option D, use restricted.googleapis.com to access Google APIs using a set of IP addresses only routable from within Google Cloud, which are advertised as routes over the cloud interconnect connection.
To arrive at the correct answer, we focus on the keywords. On-premises applications can only access Google APIs over the cloud interconnect. Only use APIs that are supported by VPC Service Controls.
The correct answer is option D, use restricted.googleapis.com to access Google APIs using a set of IP addresses only routable from within Google Cloud, which are advertised as routes over the cloud interconnect connection.
Why is this correct? D. Using restricted.googleapis.com ensures access is strictly limited to APIs supported by VPC Service Controls, fulfilling the requirement to prevent access to non-supported APIs and mitigating data exfiltration risks. Why are the others incorrect? A. Private Google access only applies to instances within the VPC, not on-premises routing, and does not limit access to APIs supported by VPC Service Controls. B. The All APIs bundle allows access to Google APIs that are not supported by VPC Service Controls, violating the strict requirement to mitigate exfiltration risks. C. The private.googleapis.com endpoint provides access to most Google APIs, including those not supported by VPC Service Controls, failing to meet the security requirement.
Your organization hosts a financial services application running on Compute Engine instances for a third-party company. The third-party company's servers that will consume the application also run on Compute Engine in a separate Google Cloud organization. You need to configure a secure network connection between the Compute Engine instances. You have the following requirements. The network connection must be encrypted. Communication between servers must be over private IP addresses. What should you do? The options are: Option A, configure a cloud VPN connection between your organization's VPC network and the third parties that is controlled by VPC firewall rules. Option B, configure a VPC peering connection between your organization's VPC network and the third parties that is controlled by VPC firewall rules. Option C, configure a VPC Service Controls perimeter around your Compute Engine instances, and provide access to the third party via an access level. Option D, configure an Apigee proxy that exposes your Compute Engine hosted application as an API, and is encrypted with TLS, which allows access only to the third party.
To arrive at the correct answer, we focus on the keywords. Separate Google Cloud organization. The network connection must be encrypted. The communication between servers must be over private IP addresses.
The correct answer is option B, configure a VPC peering connection between your organization's VPC network and the third parties that is controlled by VPC firewall rules.
Why is this correct? B. VPC peering provides private IP connectivity between VPC networks, even across different organizations. Google Cloud automatically encrypts all traffic between compute engine instances on its backbone network, satisfying both requirements. Why are the others incorrect? A. Cloud VPN is unnecessary and adds overhead because both VPCs are within Google Cloud, where VPC peering provides a simpler, natively encrypted private connection. C. VPC Service Controls are designed to mitigate data exfiltration for Google-managed services, like cloud storage, not for establishing private VM-to-VM networking across organizations. D. Configuring an Apogee proxy introduces unnecessary architectural complexity and is meant for API management, not for establishing fundamental private IP network connectivity between instances.
You are backing up application logs to a shared cloud storage bucket that is accessible to both the administrator and analysts. Analysts should not have access to logs that contain any personally identifiable information, PII. Log files containing PII should be stored in another bucket that is only accessible to the administrator. What should you do? The options are: Option A, upload the logs to both the shared bucket and the bucket with PII that is only accessible to the administrator. Use the Cloud Data Loss Prevention API to create a job trigger. Configure the trigger to delete any files that contain PII from the shared bucket. Option B, on the shared bucket, configure Object Lifecycle Management to delete objects that contain PII. Option C, on the shared bucket, configure a cloud storage trigger that is only triggered when PII is uploaded. Use Cloud Functions to capture the trigger and delete the files that contain PII. Option D, use pub/sub and Cloud Functions to trigger a Cloud Data Loss Prevention scan every time a file is uploaded to the administrator's bucket. If the scan does not detect PII, have the function move the objects into the shared cloud storage bucket.
To arrive at the correct answer, we focus on the keywords, accessible to both the administrator and analysts. Analysts should not have access to logs that contain any personally identifiable information, PII. Log files containing PII should be stored in another bucket that is only accessible to the administrator.
The correct answer is option D. Use pub/sub and Cloud Functions to trigger a Cloud Data Loss Prevention scan every time a file is uploaded to the administrator's bucket. If the scan does not detect PII, have the function move the objects into the shared cloud storage bucket.
Why is this correct? D. Uploading to the restricted bucket first ensures no PII is exposed. Cloud Functions triggered by pub/sub invoke the DLP API to scan files. Safe files are then moved to the shared bucket, fulfilling the security requirements. Why are the others incorrect? A. Uploading directly to the shared bucket exposes PII to analysts before the DLP API can scan and delete it, violating the security requirements. B. Object Lifecycle Management manages objects based on metadata, like age or storage class, not their contents. It cannot scan for or identify PII. C. Cloud storage triggers cannot natively determine if an uploaded file contains PII. You need a service like the DLP API to inspect the content.
The security operations team needs access to the security-related logs for all projects in their organization. They have the following requirements: follow the least privilege model by having only view access to logs, have access to admin activity logs, have access to data access logs, have access to access transparency logs. Which identity and access management, IAM, role should the security operations team be granted? The options are: Option A, roles/logging.private log viewer. Option B, roles/logging.admin. Option C, roles/viewer. Option D, roles/logging.viewer.
To arrive at the correct answer, we focus on the keywords, least privilege model, only view access to logs, admin activity logs, data access logs, access transparency logs.
The correct answer is option A, roles/logging.private log viewer.
Why is this correct? A. The private logs viewer role, roles/logging.private log viewer, grants read-only access, satisfying the least privilege requirement, while specifically providing the required access to data access and access transparency logs, which standard viewers cannot see. Why are the others incorrect? B. Role/logging.admin grants full administrative control over logging, which violates the requirement for the least privilege model and only having view access. C. Role/viewer is a basic role providing broad read access to many resources, but it lacks the specific permissions required to view data access and access transparency logs. D. Role/logging.viewer grants read-only access to standard logs, but it does not provide access to view data access or access transparency logs as required.
You are managing a set of Google Cloud projects that are contained in a folder named Data Warehouse. A new data analysis team has been approved to perform data analysis for all BigQuery data in the projects within the Data Warehouse folder. They should only be able to read the data and not have permissions to modify or delete the data. You want to reduce the operational overhead of provisioning access while adhering to the principle of least privilege. What should you do? The options are: Option A, grant the BigQuery data viewer role at the project level for each project within the Data Warehouse folder. Option B, grant the BigQuery data viewer role at the Data Warehouse folder. Option C, grant the BigQuery data viewer role at the dataset level for each BigQuery dataset within each project in the Data Warehouse folder. Option D, grant the BigQuery metadata viewer role at the Data Warehouse folder.
To arrive at the correct answer, we focus on the keywords: folder named Data Warehouse, all BigQuery data in the projects within the Data Warehouse folder, only be able to read the data, reduce the operational overhead.
The correct answer is option B, grant the BigQuery data viewer role at the Data Warehouse folder.
Why is this correct? B. Granting the BigQuery data viewer role at the folder level allows permissions to be inherited by all projects within it, minimizing operational overhead while only allowing data reading. Why are the others incorrect? A. Granting access at the project level requires applying the role individually to every project, which significantly increases operational overhead compared to granting it once at the folder level. C. Granting access at the dataset level requires managing permissions for every single dataset across all projects, creating massive operational overhead, which contradicts the goal. D. The BigQuery metadata viewer role only allows users to view metadata, like table names and schemas, not the actual table data required for performing data analysis.
Your financial services company needs to process customer personally identifiable information, PII, for analytics while adhering to strict privacy regulations. You must transform this data to protect individual privacy to ensure that the data retains its original format and consistency for analytical integrity. Your solution must avoid full irreversible deletion. What should you do? The options are: Option A, use Cloud Key Management Service, Cloud KMS, to encrypt the entire dataset with a customer-managed encryption key, CMEK. Option B, set up VPC Service Controls around the BigQuery project. Implement row-level encryption. Option C, implement a custom BigQuery user-defined function, UDF, by using JavaScript to hash all sensitive fields before they are loaded into the analytical tables. Option D, configure sensitive data protection, SDP, to de-identify PII using format preserving encryption, FPE.
To arrive at the correct answer, we focus on the keywords: personally identifiable information, PII, transform this data, retains its original format, avoid full irreversible deletion.
The correct answer is option D, configure sensitive data protection, SDP, to de-identify PII using format preserving encryption, FPE.
Why is this correct? D. Format preserving encryption, FPE, in sensitive data protection, SDP, securely transforms data while preserving its original format and length. It supports reversible de-identification, which maintains analytical integrity without permanent data loss, perfectly satisfying all requirements. Why are the others incorrect? A. Encrypting the entire dataset with Cloud KMS does not transform the PII into a format-preserved state for analytics, it only protects data at rest. B. VPC Service Controls provide perimeter security, and row-level encryption doesn't transform data while retaining its original format for analytical processing. C. Hashing is an irreversible one-way function, directly violating the explicit requirement to avoid full irreversible deletion of the data.
You work at a company in a regulated industry and are responsible for ongoing security of the cloud environment. You need to prevent and detect misconfigurations in a particular folder based on specific compliance policies. You need to adhere to industry-specific compliance policies and policies that are internal to your company. What should you do? The options are: Option A. Create a posture file by using custom and predefined SHA or organization policies. Enforce the posture on the folder level. Option B. Create custom organization policies that follow specific business requirements. Enforce the policies on the folder level. Option C. Enable assured workloads on the folder level, with the specific control bundle appropriate for your industry's regulations. Option D. Use Workload Manager with custom REGO policies to continuously scan the environment for misconfigurations on the folder level.
To arrive at the correct answer, we focus on the keywords: prevent and detect misconfigurations, particular folder, industry-specific compliance policies, policies that are internal to your company.
The correct answer is Option A. Create a posture file by using custom and predefined SHA or organization policies. Enforce the posture on the folder level.
Why is this correct? A. Security Command Center Posture Management lets you combine predefined policies for industry regulations and custom policies for internal rules. Deploying this posture at the folder level effectively provides both preventative and detective controls for misconfigurations. Why are the others incorrect? B. Organization policies provide preventative controls but lack built-in detective capabilities. They also do not offer the pre-packaged industry compliance policy sets available through Security Health Analytics (SHA) in posture management. C. Assured Workloads creates controlled environments for specific regulatory regimes but does not provide the flexibility to define and enforce custom, internal misconfiguration policies across a folder like posture management. Why are the others incorrect? D. Workload Manager evaluates specific enterprise workloads against best practices. It is not intended for general cloud resource misconfiguration scanning or enforcing custom REGO policies at the folder level.
Your organization has established a highly sensitive project within a VPC Service Controls perimeter. You need to ensure that only users meeting specific contextual requirements such as having a company-managed device, a specific location, and a valid user identity can access resources within this perimeter. You want to evaluate the impact of this change without blocking legitimate access. What should you do? The options are: Option A. Establish a context-aware access policy that specifies the required contextual attributes, and associate the policy with the VPC Service Controls perimeter in dry run mode. Option B. Use the VPC Service Control Violation Dashboard to identify the impact of details about access denials by service perimeters. Option C. Configure a VPC Service Controls perimeter in dry run mode, and enforce strict network segmentation using firewall rules. Use multi-factor authentication, MFA, for user verification. Option D. Use cloud audit logs to monitor user access to the project resources. Use post-incident analysis to identify unauthorized access attempts.
To arrive at the correct answer, we focus on the keywords: VPC Service Controls perimeter, specific contextual requirements, company-managed device, specific location. Evaluate the impact of this change without blocking legitimate access.
The correct answer is Option A. Establish a context-aware access policy that specifies the required contextual attributes, and associate the policy with the VPC Service Controls perimeter in dry run mode.
Why is this correct? A. Context-aware access enables access control based on context attributes like device management and location. Associating it in dry run mode safely evaluates the impact without disrupting legitimate access. Why are the others incorrect? B. The violation dashboard only displays access denials from existing perimeters and cannot enforce contextual requirements or evaluate new policies proactively. C. Firewall rules and MFA verify network paths and identity but cannot enforce dynamic contextual attributes like device management state or specific locations. D. Using cloud audit logs for post-incident analysis is purely reactive and fails to proactively enforce contextual access controls or evaluate their impact.
Your company's storage team manages all product images within a specific Google Cloud project. To maintain control, you must isolate access to cloud storage for this project, allowing the storage team to manage restrictions at the project level. They must be restricted to using corporate computers. What should you do? The options are: Option A, use Identity and Access Management (IAM) roles at the project level within the storage team's project. Grant the storage team granular permissions on the project's cloud storage resources. Option B, employ organization-level firewall rules to block all traffic to cloud storage. Create exceptions for specific service accounts used by the storage team within their project. Option C, use context-aware access. Create an access level that defines the required context. Apply it as an organization policy specifically at the project level, restricting access to cloud storage based on that context. Option D, implement VPC Service Controls by establishing an organization-wide service perimeter with all projects. Configure ingress and egress rules to restrict access to cloud storage based on IP address ranges.
To arrive at the correct answer, we focus on the keywords: isolate access to cloud storage for this project, manage restrictions at the project level, restricted to using corporate computers.
The correct answer is option C, use context-aware access. Create an access level that defines the required context. Apply it as an organization policy specifically at the project level, restricting access to cloud storage based on that context.
Why is this correct? C. Context-aware access allows restricting access based on device identity, such as requiring corporate computers. Applying this as an organization policy at the project level fulfills the requirement for the storage team to manage project-level restrictions. Why are the others incorrect? A. IAM roles control who has access to resources but cannot enforce context-based restrictions like requiring the use of corporate computers. B. Organization-level firewall rules apply to VPC networks and VM instances, not directly to Google Cloud APIs like cloud storage. D. VPC Service Controls can restrict access by IP address, but it cannot specifically verify device posture or ensure the use of corporate computers.
Your organization uses Google Workspace as the primary identity provider for Google Cloud. Users in your organization initially created their passwords. You need to improve password security due to a recent security event. What should you do? The options are: Option A, conduct a security awareness training session, and set the password expiration settings to require more frequent updates. Option B, check the Enforce Strong Password box, and check Enforce Password policy at the next sign-in. Option C, check the Enforce Strong Password box, and set the password expiration to occur more frequently. Option D, audit user activity for suspicious logins by using the Audit and Investigation tool.
To arrive at the correct answer, we focus on the keywords: Google Workspace, improve password security, recent security event.
The correct answer is option B, check the Enforce Strong Password box, and check Enforce Password policy at the next sign-in.
Why is this correct? B. Enforcing a strong password directly addresses password security, and enforcing it at the next sign-in ensures that all users immediately update their potentially compromised passwords following the security event. Why are the others incorrect? A. Security training and frequent password expirations do not immediately enforce strong passwords, which is a critical requirement immediately following a security event. C. While enforcing strong passwords is correct, frequent expiration often leads to predictable passwords. Enforcing the policy at the next sign-in is more crucial to address the recent event. D. Auditing user activity is a reactive investigative measure, not a proactive technical control that will immediately improve users' password security.
Your company has deployed an artificial intelligence model in a central project. This model has a lot of sensitive intellectual property and must be kept strictly isolated from the internet. You must expose the model endpoint only to a defined list of projects in your organization. What should you do? The options are: Option A, within the model project, create an internal application load balancer that points to the model endpoint. Expose this load balancer with Private Service Connect to a configured list of projects. Option B, activate private Google access in both the model project and in each project that needs to connect to the model. Create a firewall policy to allow connectivity to private Google access addresses. Option C, create a central project to host shared VPC networks that are provided to all other projects. Centrally administer all firewall rules in this project to grant access to the model. Option D, within the model project, create an external application load balancer that points to the model endpoint. Create a Cloud Armor policy to restrict IP addresses to Google Cloud.
To arrive at the correct answer, we focus on the keywords, strictly isolated from the internet, expose the model endpoint only to a defined list of projects.
The correct answer is option A. Within the model project, create an internal application load balancer that points to the model endpoint. Expose this load balancer with Private Service Connect to a configured list of projects.
Why is this correct? A. Private Service Connect allows you to expose services using internal IP addresses, ensuring strict isolation from the internet. It provides granular control, allowing you to publish the endpoint and explicitly authorize only a defined list of consumer projects to connect. Why are the others incorrect? B. Private Google Access allows internal IPs to reach Google Cloud APIs and services, not custom endpoints hosted in other VPCs. It does not securely expose a specific internal service across different projects. C. Shared VPC merges networks rather than exposing a specific endpoint. It provides broad network-level access rather than the required targeted, service-centric access to a defined list of projects, increasing the blast radius. Why are the others incorrect? D. Creating an external application load balancer assigns public IP addresses to the service. This violates the core requirement to keep the sensitive intellectual property strictly isolated from the internet, regardless of Cloud Armor restrictions.
You manage multiple internal-only applications that are hosted within different Google Cloud projects. You are deploying a new application that requires external internet access. To maintain security, you want to clearly separate this new application from internal systems. Your solution must have effective security isolation for the new externally facing application. What should you do? The options are: Option A, deploy the application within the same project as an internal application. Use a shared VPC model to manage network configurations. Option B, place the application in the same project as an existing internal application and adjust firewall rules to allow external traffic. Option C, create a VPC Service Controls perimeter and place the new applications project within that perimeter. Option D, create a new project for the application and use VPC network peering to access necessary resources in the internal projects.
To arrive at the correct answer, we focus on the keywords, internal-only applications, hosted within different Google Cloud projects, deploying a new application that requires external internet access, clearly separate this new application from internal systems, effective security isolation.
The correct answer is option C. Create a VPC Service Controls perimeter, and place the new applications project within that perimeter.
Why is this correct? C. Creating a VPC Service Controls perimeter provides robust security isolation at the project level, mitigating data exfiltration risks and effectively separating the externally facing application from internal systems. Why are the others incorrect? A. Placing the external application in the same project as an internal one fails to provide clear separation or effective security isolation, violating the principle of least privilege. B. Mixing internal and external applications in the same project weakens isolation and increases the risk of misconfiguration, failing to clearly separate the new application from internal systems. D. VPC network peering connects the networks directly, which undermines the goal of clearly separating the externally facing application from internal systems and reduces security isolation.
Your company hosts a critical web application on Google Cloud. The application is experiencing an increasing number of sophisticated Layer 7 attacks, including cross-site scripting, XSS, and SQL injection attempts. You need to protect the application from these attacks while minimizing the impact on legitimate traffic and ensuring high availability. What should you do? The options are: Option A, implement a load balancer in front of the web application instances, and enable adaptive protection and throttling to mitigate the occurrence of these malicious requests. Option B, configure Cloud Next Generation Firewall to block known malicious IP addresses targeting /32 addresses. Option C, enable Google Cloud Armor's pre-configured WAF rules for OWASP Top 10 vulnerabilities at the backend service. Option D, configure a Cloud Armor security policy with customized and pre-configured WAF rules for OWASP Top 10 vulnerabilities at the load balancer.
To arrive at the correct answer, we focus on the keywords: Layer 7 attacks, cross-site scripting, XSS, SQL injection attempts, minimizing the impact on legitimate traffic, high availability.
The correct answer is option D. Configure a Cloud Armor security policy with customized and pre-configured WAF rules for OWASP Top 10 vulnerabilities at the load balancer.
Why is this correct? D. Cloud Armor security policies with WAF rules deployed at the load balancer directly mitigate OWASP Top 10 vulnerabilities like XSS and SQL injection, ensuring Layer 7 protection and high availability. Why are the others incorrect? A. Adaptive protection and throttling are primarily designed for mitigating Layer 7 DDoS attacks, not specifically addressing application-level vulnerabilities like XSS or SQL injection. B. Cloud Next Generation Firewall operates at Layers 3 and 4 and cannot inspect the Layer 7 payloads necessary to detect and block XSS or SQL injection attacks. C. You must configure a Cloud Armor security policy to apply WAF rules. Furthermore, customized rules are often needed alongside pre-configured ones to minimize false positives and impact on legitimate traffic.
Your team maintains 1 PB of sensitive data within BigQuery that contains personally identifiable information, PII. You need to provide access to this dataset to another team within your organization for analysis purposes. You must share the BigQuery dataset with the other team while protecting the PII. What should you do? The options are: Option A, utilize BigQuery's row-level access policies to mask PII columns based on the other team's user identities. Option B, export the BigQuery dataset to cloud storage. Create a VPC service control perimeter and allow only their team's project access to the bucket. Option C, implement data pseudonymization techniques to replace the PII fields with non-identifiable values. Grant the other team access to the pseudonymized dataset. Option D, create a filtered copy of the dataset and replace the sensitive data with hash values in a separate project. Grant the other team access to this new project.
To arrive at the correct answer, we focus on the keywords: contains personally identifiable information, PII, provide access to this dataset to another team, protecting the PII.
The correct answer is option C. Implement data pseudonymization techniques to replace the PII fields with non-identifiable values. Grant the other team access to the pseudonymized dataset.
Why is this correct? C. Pseudonymization replaces sensitive PII with artificial identifiers or tokens. This effectively protects the PII while preserving data utility, allowing the other team to perform necessary analysis on the dataset. Why are the others incorrect? A. Row-level access policies filter entire rows based on user identity. They cannot be used to mask or redact specific columns containing PII. Column-level security or dynamic data masking would be required instead. B. Exporting the data to cloud storage and restricting access using VPC Service Controls protects the perimeter but does not protect the PII within the data itself. The other team would still see the plaintext PII. D. Manually creating a copy and replacing sensitive data with hash values is operationally complex for 1 PB of data, duplicates storage costs, and is less robust than standardized pseudonymization techniques.
You are working with developers to secure custom training jobs running on Vertex AI. For compliance reasons, all supported data types must be encrypted by key materials that reside in the Europe region and are controlled by your organization. The encryption activity must not impact the training operation in Vertex AI. What should you do? The options are: Option A, encrypt the code, training data, and metadata with Google Default Encryption. Use Customer-Managed Encryption Keys, CMEK, for the trained models exported to cloud storage buckets. Option B, encrypt the code, training data, metadata, and exported trained models with Customer-Managed Encryption Keys, CMEK. Option C, encrypt the code, training data, and exported trained models with Customer-Managed Encryption Keys, CMEK. Option D, encrypt the code, training data, and metadata with Google Default Encryption. Implement an organization policy that enforces a constraint to restrict the Cloud KMS location to the Europe region.
To arrive at the correct answer, we focus on the keywords: secure custom training jobs running on Vertex AI. All supported data types must be encrypted by key materials, controlled by your organization.
The correct answer is option B, encrypt the code, training data, metadata, and exported trained models with Customer-Managed Encryption Keys, CMEK.
Why is this correct? B. Vertex AI supports Customer-Managed Encryption Keys, CMEK, allowing you to encrypt all supported data types, code, training data, metadata, and exported models, with keys controlled by your organization in a specific region. Why are the others incorrect? A. Using Google Default Encryption for code, training data, and metadata fails the requirement to encrypt all supported data types with keys controlled by your organization. C. This option omits metadata. Vertex AI requires you to protect all supported data types, including metadata, with CMEK to fully meet the organization's compliance requirements. D. Google Default Encryption does not use keys controlled by your organization, CMEK. Restricting the Cloud KMS location is insufficient if CMEK is not applied to the required data types.